बर्तमान देखा आम तापरे नेक्स्ट ओम्स लॉ फर्स्ट व्हाट इज ओम्स लॉ सो ओम्स लॉ कौन ना एट कांस्टेंट टेम्परेचर फॉर ए गिवन डायमेंशंस ऑफ द कंडक्टर the strength of electric current through a conductor is directly proportional to the potential difference applied across the conductor. So, if we keep temperature constant and for a given conductor, the current flowing through conductor is directly proportional to potential difference applied, or I is equal to 1 by R into V, where R is called electrical resistance of the conductor. So, 1 by R is the proportionality constant and R is called electrical resistance of the conductor. It is according to Ohm's law is equal to I is equal to V by R. Then what is the resistance? So, resistance is equal to R is equal to V by I, that is potential difference V to the current I. So, resistance also defined as the current passing through the conductor is said to be resistance of the conductor when the ratio of potential difference across the ends of the conductor and the current passing through the conductor is said to be resistance of the conductor. So, resistance, or it is the opposition offered by the conductor to flow of current through it is called resistance. So, resistance also that is V by I. When V changes, I changes, but R always remains same in a conductor. So, what is the unit of resistance? It is ohm. So, OHM, or it is symbol is ohm, omega. So, it is volt per ampere. That is 1 ohm is equal to 1 volt per 1 ampere, and the dimensional formula is equal to ml square t to the power minus 3 a to the power minus 2. Now, we define ohm. What is ohm? If V is equal to 1 volt and I is equal to 1 ampere, then R is equal to 1 ohm. So, the resistance of a conductor is said to be 1 ohm if 1 ampere current passes through a conductor having a potential difference of 1 volt across its ends. So, this is the symbols of resistance, circuit symbol, means symbolically how we mention a resistance in the circuit. This is for a constant resistance and this is a variable resistance, or it is called, actually this is here, the line is here in this way, arrow mark. So, this is the variable resistance, or it is called rheostat. It is called rheostat. So, current, electricity, now these are the atoms, these are the electrons, and these are free electrons, and these are the ions. So, these are the fundamental understanding of a resistance of a wire. So, opposition to the flow of current in a conductor due to collision of electrons with the ions and the atoms of the conductor termed as resistance of the wire or conductor. When these free electrons collide with the ions or atoms, the speed of electron decreases as a current decreases. That is why this opposition offered is called resistance of conductor. So, now we देखिबा what are the factors influencing the resistance of a conductor, माने को factor उपरे resistance of a conductor depend करे. So, resistance of a conductor depends on the nature of the material of the conductor, means for different conductors, means like iron, copper, aluminum, all materials they have different resistances, means different materials mean different resistance. Then second, directly proportional to length of the wire. So, gote conductor suppose L is the length, then the resistance of conductor or wire is directly proportional to length and inversely proportional to area of a cross section of the conductor. if A is the area of cross section of the conductor, so R is inversely proportional to area of cross section of the conductor. So therefore, another quantity that resistance depends is the temperature of the conductor or temperature of the wire. Therefore, we see that R resistance is directly proportional to length of the conductor, and R is also inversely proportional to area of the conductor, area of cross section of a conductor. And when we combine these two, it will be R is directly proportional to L by A, or R is equal to rho L by A, where rho is called resistivity of the conductor. So R is equal to rho L by A. So rho is called resistivity of the conductor. So here rho is called resistivity of conductor, or it is called specific resistance. Specific resistance of conductor, and its value depends on nature of the conductor and temperature of the conductor, but independent of dimension of the conductor. Length किंबा area of conductor उपरे किछि depend करे नहीं. Therefore, we can write rho is equal to R into A by L. When A is equal to 1, L is equal to 1, rho is equal to R. Therefore, we can write or define resistivity of a conductor is defined as the resistance of the conductor of unit length and unit cross sectional area, and the SI unit of resistivity is equal to ohm meter, or that is ohm meter. So this is the resistivity. So resistivity only depends on temperature of the conductor and material of the conductor. So now we see some knowledge. Ohm's law is neither a basic law nor a derivable one. V is equal to IR, just an empirical relation. Microscopically, Ohm's law is expressed as V is equal to I by L sigma A, where sigma is called electrical conductivity of the material, and current density is equal to NEVD, or sigma into E, conductivity into electric field. When potential difference is applied to the ends of the conductor, then free electron get accelerated. As they move, they collide against the atoms and ions, and thus their motion is opposed. So this opposition offered to flow of charge through a conductor is called resistance. So the resistance of a conductor depends on nature of the material, dimensions of conductor, and physical conditions like temperature, pressure, and dimensions like length, cross section, etc. Button dekhiba, what is conductance? So the conductance of a conductor is defined as the reciprocal of a resistance, and it is denoted as G is equal to 1 by R. So SI unit is ohm inverse or takanti Siemens, and dimensional formula M inverse L to the power minus 2 T to the power 3 and A square. Then similarly conductivity. So conductivity, similarly you can write conductivity. So conductivity is defined as, it is the reciprocal of resistivity. It is the reciprocal of resistivity. So that is sigma is equal to 1 by rho, and the SI unit is ohm inverse meter inverse or Siemens into meter inverse. So this is called resistivity. We see that is mathematical form of आमे देखिबा form of Ohm's law. We know current in terms of a drift velocity I is equal to NEA VD and drift velocity is equal to E V tau by m into L, where V is the potential difference applied across the conductor of length L. Therefore, you can write I is equal to N E A into E V tau by m into L. So it will be N square A into tau by m into L into V, or that implies I is equal to V by R, where R is equal to m by n square tau into L by A. So it is, that is L by A, or that implies R is equal to rho L by A, where rho is equal to m by n square tau. So this is the expression of resistivity, this is the expression of resistance, and this is the expression of I is equal to V by R, which is Ohm's law. तेणु युड़क आम एमती डिराइव कर तेणु आम देखिलु रेजिस्टिविटी ऑफ कंडक्टर इनवर्सली प्रोपोर्शनल टू रिलैक्सेशन टाइम. सो नाउ फ्रॉम दिस फॉर्मूला आम देखि पारिबा केमिति टेम्परेचर चेंज हेले रेजिस्टिविटी चेंज होउछि. गोटे कंडक्टर रे जदि टेम्परेचर बढ़िबो ताल इलेक्ट्रॉन विल मूव फास्टर. इलेक्ट्रॉन जो फास्टर मूव करेंगे कोलिजन मध्य फास्टर हम, जाफल कोलिजन टाइमटा बा रिलैक्सेशन टाइमटा कमी जीव. मीन्स गोटे इलेक्ट्रॉन गोटे जाकि आउ गोटे इलेक्ट्रॉन को कोलिजन होगापाई जो समय लगे से समयटा कमीजीव. तेना रिलैक्सेशन टाइम और कोलिजन टाइम रिलैक्सेशन टाइम कमीजीव तो रेजिस्टिविटीटा कौन हम बढ़ीज ऑटोमेटिक. देयरफॉर टेम्परेचर बढ़िले रिलैक्सेशन टाइम कमिबो एवं रेजिस्टिविटी बढ़िबो. तेणु टेम्परेचर बढ़िले रेजिस्टिविटी कंडक्टर बढ़िबो, टेम्परेचर कमिले रेजिस्टिविटी कंडक्टर रे कमिबो. Limitations of Ohm's law. Although Ohm's law has been found valid over a large class of materials, there do exist materials and devices used in electric circuit where the proportionality of V and I does not hold. Means the Ohm's law is basically valid for or used for ohmic conductor. means the through conductor in which current or voltage they are related directly proportional to each other, then the conductor is ohmic conductor, and the VI graph of ohmic conductor will be a straight line passing through origin. So, this is voltage current graph. So, VI graph is a straight line passing, so then it is called ohmic conductor. So, if it is not a straight line, then it is called no ohmic conductor. Therefore, the derivations broadly are one or more of the following types. V ceases to be proportional to I, and the relation between V and I depends on the sign of V. So, if I is the current for a certain voltage V, then reversing the direction of V, keeping its magnitude fixed, does not produce a current of the same magnitude as I in the opposite direction. So, the dashed line represents the linear Ohm's law, and the solid line is the voltage V versus current I for a good conductor. So, this is for a, actually this is the ohmic conductor, but it is the for good conductor it will actually, this much means gradually slightly increasing. So, here this is the characteristic curve of a diode. In diode valve, so VI characteristics, this is the forward bias and this is the reverse bias, so it is a curve, so it is a non-ohmic conductor. So, Ohm's law is not valid in case of a diode. So, this is the gallium arsenide. Gallium arsenide is a compound semiconductor. So, in this conductor, if we apply voltage, the current variation will be in this way. That means, we get same current for different voltages, which is not possible. Therefore, these are also non-ohmic conductor. So, the relation between voltage and current is not unique, that is, there is more than one value of V for the same current I. A material exhibiting such behavior is gallium arsenide. Materials and devices not obeying Ohm's law are actually widely used in electric currents. So, Ohm's law is not a fundamental law like Newton's law, as it is not obeyed by all substances. It is an empirical formula just used to find potential difference across the conductor. Ohm's law is valid only for linear conductors in which VI ratio is constant, such as materials, that is V by I ratio is constant. At a constant temperature, for given dimensions of a conductor, the strength of electric current through a conductor is dash to be potential difference applied across the conductor. So, the alternate choice question, so the options are directly proportional, inversely proportional, equal, not equal. So, strength of electric current through a conductor is directly proportional to potential difference applied across the ends of the conductor. The symbols for variable resistance is, so this is the constant resistance, this is the variable resistance, and this is the inductor, and this is the variable inductor, we can say. So, the correct option is B. So, variable resistance, or it is called rheostat. So, ohmic and non-ohmic conductors, we see that ohmic conductors. The substance which obey the Ohm's law are called ohmic conductors, example is metal. So, the graph between voltage and current in these conductors are straight line passing through origin. Here, slope of this line I is equal to tan theta is equal to I by V is equal to 1 by R. 1 by R is equal to reciprocal of resistance is the conductance. And if we draw graphs V in y axis and current in y axis, then slope tan theta is equal to V by I is equal to R. Non-ohmic conductors. Substances which do not obey Ohm's law are called non-ohmic conductors. Example, electrolytes, thermoionic valves, thermistors, semiconductors, vacuum tubes, transistors, etc. Because in this case, or when current flows through these conductors, the VI graph is not a straight line passing through origin. So, these are called non-ohmic conductors. So, a thermistor is a non-ohmic device in which VI curve for a thermistor is in this way. Means, so there will be for same voltage there will be different currents. We get different current. One voltage, same voltage, for there will be more than one current. So, VI curve for a semiconductor PN junction diode is, so this is the forward bias and this is the reverse bias. So, it is VI graph for a PN junction diode. So, VI graph for a vacuum tube is not a straight line. So, it will be this. So, it is a non-ohmic conductor. बर्तमान देखा सेमती केतरा मल्टीपल चॉइस क्वेश्चंस. फर्स्ट क्वेश्चन, ओम्स लॉ इज एप्लीकेबल टू, ऑप्शंस आर ohmic conductors only, non-ohmic conductors only, both ohmic and non-ohmic conductors only, and option D vacuum tubes only. So, the correct option is ohmic conductor only. Ohmic conductor means in conductor in which current voltage linearly varies, means it is a graph is a straight line. The resistance of a conductor is inversely proportional to the length, directly proportional to square of the radius, inversely proportional to square of the radius, and directly proportional to square root of the length. So, the correct option is the option C, that is inversely proportional to square of the radius, because आमे जानिचु resistance of a conductor is inversely proportional to area of a cross section. So, area of a cross section means it is equal to pi r square, where r is the radius of the conductor. Therefore, resistance of a conductor inversely proportional to square of the radius of the conductor.